Hello, my friends, and welcome to a lesson about geometric multiplication. It's a visual way of looking at the multiplication work you've been doing. And you know, if you've been working with that checkerboard and you're missing it a lot, or wherever you were with that material, this carries some of that work onwards. It's pretty cool. What do you need? A piece of graph paper, a straight edge or a ruler, and colored pencils. And you will need a green, blue, and red colored pencil. Recognize these colors? Fantastic. And of course, you'll need a problem. Well, you know me, I love folding my paper in half and getting set up. And let's try the problem. 5,614 times 23. That might be something you do on the checkerboard. It's a little bit of long multiplication. 2 digits in the multiplier, and you might even be able to visualize it on the checkerboard. You don't visualize it here though yet, do you? Well, let's make it visual. You'll need your straight edge for this part. First, go ahead and write down the problem. 5,614 times 23. Awesome. Now we need to make a rectangle. We're actually going to make our own checkerboard appear, but it won't look quite like the checkerboard that you know. You see that top number, 5,614. We are going to make a line that matches by length each digit of the multiplicand. What do I mean by that? I mean, take your straight edge and go ahead and mark off 5 boxes for that 5,000. You can create a small notch just to help you out with this. What do you think the next line is going to be? 6. And I'm notching that. And then there's just 1. And then there's 4. So your line should be notched at 5, 6, 1, and 4 squares. And I'm going to give you a close-up look to see what that looks like. Check it out. 5, 6, 1, 4. Now down the next line here, we're going to put 23 the same way, going 2, then 3. Let's do it. Take your straight edge, go ahead and mark off 2, small notch maybe, and then go ahead and mark off 3. And now enclose your rectangle. And each place you put a notch, please extend a line from that point. So you have this one right here to go horizontally, and you'll have several that will go vertically. And so you'll end up with something that looks like this. Take a look at that box. It's defined by our multiplication problem. Horizontally, it's defined by our multiplicand, and vertically, it's defined by our multiplier. So let's go ahead and attach some numbers to this. On the bottom, we're going to mark off to the right each number for each box or rectangle. And along the side as well, 23. And there's what that looks like labeled. Check it out. Pretty cool. Now we're going to color this thing like the checkerboard with our colored pencils of green, blue, and red. So visualize that checkerboard. Remember, units, tens, hundreds, thousands, and then do you remember what starts the next row? That's right, there isn't a unit. We'll do tens, hundreds, thousands, 10,000. So, in other words, green, blue, red, green, blue, red, green, blue. Let's make it happen. This part might take a little bit, so I like to do it like this. Ta-da! It looks just like a little checkerboard that maybe got left out too long in the sun and warped or something, but really what's happening here is it is defined by your multiplicand and multiplier, which is changing the dimensions of the squares. Well, now that we're set up, and yes, the initial setup takes a little bit of time, but once you do this a couple times, you'll get really good at it. Well, let's go ahead and solve our problem. Now, by breaking up our problem this way, we've actually broken up the math we have to do to solve it. We can go step by step, just like on the checkerboard. We will need a little bit of power from our math facts. So grab that power and get ready. The first one, do you see what we're doing here? We are going to be multiplying 4 3 times. We're going to write that inside the box. And then solve it. What is 4 times 3 anyway? 12. Let's go ahead and write that down. And here's a close-up just to show you what that's going to start to look like. Let's move on to the next one. We have 1 taken 3 times. 1 times 3 is, yes, 3. And we just sort of crunched that one in there. You'll want to be careful. You know, we will have to get things pinched in a little bit, especially in that top row. But be clean and easy with your work. You want to be able to read it. All right, let's move on to the next one. 6 taken 3 times, which is equal to 18. And 5 taken 3 times, using those fantastic math facts, will tell you 15. Okay, so now we have these several little bits here. We'll come back to those in just a moment because now we're going to do the tens row. And the first thing we see is 4 taken 2 times. And I'm going to crunch that in there, but I'm going to write it still very clearly. And 4 taken 2 times is 8. Here, have another glance of what that's looking like so far. And let's move on. 1 taken 2 times is 2. Now, when you do a larger tens digit for your multiplier, you will have more space. But in this case, we only have 2. Ooh, 6 taken 2 times. 12. And of course, 5 taken 2 times. 10. But not really 10, 12, 2, and 8, is it? These numbers are not quite what they appear to be. We're going to have to do some thinking for this next step as we create our partial products. It's pretty awesome. Okay, let's take a good look, though, at our box, all filled with all the information that we'll need. Now, the thing is, these are units, tens, hundreds, thousands, and there's even 10,000s in that upper row right there. So we need to apply the right amount of zeros to each of the numbers we see in these boxes to make them actually worth what they're worth. So in the units box, how much would 12 be worth? 12, that's it. And we're going to just write that down right here. But let's talk about that 3 in a tens box. We need to think, what are 3 tens? 30. There's 1 0 behind that 3 now. And you think you would have a 3 bead bar on that 10 square. It would be worth 30. How about 18 in the 100 square? How many zeros are getting put on there? 18 hundreds is 1800, or 1800. How about that 15? It's in the thousands. It's 15 thousands, or 15,000. And as I'm writing these down, I am lining them all up just like this, with the right amount of zeros behind them. We're going to start on our top row now, and keep in mind that that first square is a 10, and it has 8 in it. So what would that be? 80. Then we have 2 hundreds, or 200. 12 thousands, or 12,000. If you actually say the number and then the category, it might even give you the answer. How about that 10 thousands? It's a little bit different, right? That's going to be 100,000 there. Now you have all of your partial products, and they should look just like this. What do you do with partial products? Well, to get that final product, we are going to add all of these up. So let's do that. There's quite a few numbers to come down through, but especially for that first column, it's 2 plus a lot of zeros. 2. 1 plus 3 plus 8. There's a 2, and we're carrying something up and over. 1 plus 8 plus 2. There's a 1, and that's from 11, a 1 coming up. 1 plus 1 plus 5 plus 2. We've got a 9, 1 plus 1, 2, and finish it off with just a 1. And there is our final answer, our product, 129,122. And we solved it with geometric multiplication. Pretty cool, huh? Well, there's another phase of this I'd like to show you as well, but I want you to practice this first and get good at it. And when your math facts are feeling strong, head on over and check out phase 2 of geometric multiplication.